Okay, so today we're looking at trig functions of special triangles. So to start this one off, we're going to go back to Math 2 geometry, and we're going to look at what our special triangles are. So we did have, really it was two, it was just the way they were oriented. We had a 30, 60, 90. We also had a 30, 60, 90. And then we also had the 45, 45, 90. And with each of these special triangles, we had a pattern that went with the side lengths. So for the first one, 30, we went across from 30, and that was 1x. The hypotenuse was 2x, and the adjacent side to 30 was root 3 times x. And so when we think about it, we usually drop the x for the trig function part, but we know that it could be any multiple. So when we look at the 30, 60, 90, when it's oriented this way, across from 60, we'd have the root 3 x. Across from 30, we'd have the 1x, and the hypotenuse would still be 2x. And then for the 45, 45, 90, it was 1x, 1x, and x root 2. So the x's again just mean we could have any multiple of these values. So if we had, let's say 2 root 3, 2, and 4, that would reduce back down to this pattern. So that's all the x's really mean when they're in there, is that it's any multiple of this ratio of sides. So when we put them onto a unit circle, because that's where we're headed to our unit circle, the x's are all 1, because our radius, which in the case of the unit circle, so if I sketch a quick unit circle here, so I do dotted first to try to get a good circle, and then I fill it in. So when we draw our angles, all of our units are 1. So, our radius is 1. So if this is 45, then we would be 1 root 2, 1, and 1. Actually, no, we wouldn't. Time out. I said that wrong. We're going to create our ratios based on the fact that our radius is only 1. So if we had a 45-degree triangle, that would be this one over here. So we would have to figure out what do we multiply by to get root 2. So x times root 2 will equal 1. That's the question we're asking for our side length, or to find out what our x is. So to find out what x is, we divide both sides by root 2. So when we go and rationalize, we end up with root 2 over 2, meaning we'd have root 2 over 2 for each of our side lengths, because that's what x is equal. And when you perform this same thing, setting each of your hypotenuse, so if I went with a 30, 60, 90, if I set 2x equal to 1, x would equal 1/2. So if we were to draw the 30, so that'd be here-ish. Again, our radius is 1, so that means our x has to be 1/2. And then when we do 1/2 times root 3, we get root 3 over 2 for the y. And then again, you can just do the same thing for the 60. So that's just how we get these. What's more important is that you guys realize what they are. And I know whenever I have trouble memorizing my unit circle, I always go back to my special triangles, because that's where it's all derived from. So if you're someone who still struggles with memorizing your unit circle, as long as you have your right triangles or your special triangles memorized, you can always fall back to those to help you figure out your different measurements. And so just some additional things you want to make sure you have is that when we talk about the cosine of x, so when we're talking about the 30, so this was 30 in here, when we talk about the 30, our adjacent was the x value, our adjacent was the x value over the hypotenuse of 1. So our cosine is always going to equal x. Sorry, I'm just messing up left and right. Our cosine of our angle is always just going to equal x over 1 because our hypotenuse will always be 1. When we talk about sine of an angle, our opposite's always going to be this height, which is our y, over 1, because again, on the unit circle, the hypotenuse is 1, which means our tangent, when we talk about opposite over adjacent, will always be y over x. And so sometimes this will help when we're looking at values on a coordinate plane or things like that to help us figure out the x and the y, or when it comes to plotting, which we will be doing. So what I would like, oops, you can't see that bottom part. What I'd like to just go through real quick is what the sine, cosine, and tangent are of our special angles. So if we were to go sine of 30, cosine of 30, because today we're just going to stick with this first quadrant. We'll get to the other quadrants tomorrow. And then we'll do 45. And then we'll do 60. So for sine of 30, that's the one I have here in pink, our opposite is, actually, yeah, sine of 30. Our opposite is root 3 over 2. Our hypotenuse is 1. Let's see, I have something backwards there, don't I? Yes, I do. This should be 1/2, and this should be the root 3 over 2. Oy. Because I placed it wrong according to my pattern. 30 opposites over here. Okay, so sorry. So our sine of 30 is 1/2. Our cosine is the y value, root 3 over 2. And our tangent would be if we were to take 1/2 divided by, which is the same as multiplying by the reciprocal, 1 over root 3, which when we rationalize becomes root 3 over 3. For 45, that's what's in purple here, I know it's hard to read, we have sine is root 2 over 2, cosine is root 2 over 2, and then when we divide root 2 over 2 times the reciprocal, root 2 over root 2, everything cancels out and we just get 1. And for 60, I don't have that one drawn, but with what we know about our special triangle, opposite is root 3, hypotenuse is 2, cosine, adjacent is 1, opposite is 2. So when we do sine and then our opposite over the reciprocal of adjacent, we get just root 3. So these are the values that you're going to be working with the most today, as well as their reciprocals. So these ones, again, should already know. These are from your unit circle, or if you want to think of it, they're from your special triangle. And so what we're going to add to our list are the reciprocal functions. Secant of 30, cosecant of 30, cotangent of 30, secant of 45, cosecant of 45, cotangent of 45, as well as secant of 60, cosecant of 60, and cotangent of 60. So one of the nice things, since we already have the first half done, we're just going to flip the fractions. So secant goes with which one? So I purposely wrote them out of order because you need to remember that secant goes with cosine. So this would actually be 2 over root 3, which when you rationalize it becomes 2 root 3 over 3. Cosecant goes with sine, so that's 2. And cotangent, I'm just going to do the reciprocal before I rationalize because that is I won't have to rationalize afterward. Then I can do the same thing with sine. So secant, again, goes with cosine. So that'll be 2 over, let's see, we'll have root 2 over 2, but it's 1 over that, so that becomes 2 over root 2, which when we rationalize will just give us root 2. Cosecant will be the same thing, because sine and cosine are the same, so secant and cosecant will be the same, and our cotangent will still be 1 because the reciprocal of 1 is 1. So lastly, for 60, secant goes with cosine, so reciprocal of 1/2 is 2. Cosecant goes with sine, so I'm going to flip that to 2 over root 3, which becomes 2 root 3 over 3. And then cotangent, 1 over root 3, which rationalizes to become root 3 over 3. So all of these are going to have to be memorized, but one of the nice things is as long as you have these top 9, like from last year, memorized, it's not that much work to go and figure out your reciprocal functions. Okay, so what you guys are working on today is pretty much just utilizing these exact values to do your assignment. So all your questions are going to be about what's the sine of blank or what's the cosine of blank. If you have any questions, we can go over them in class.